For our next example, which we have here on the board, 2x plus y is equal to 21. The condition we need to follow is x and y are positive whole numbers. That is the only condition we need to maintain. Remember the rule. You keep testing values to see what works for you. Therefore, we begin by assigning the value of 0 to x. In that case, if we assign the value of 0 to x, only y will be left. It means that y will take the whole 21. It works. So we begin by saying that when x is 0, y will be 21. That's a good one. We have found the first pair. What if we assign the value 1 to x? What happens to y? Let's test this out and check what happens to y. In that case, if I assign the value of 1 to x, 2 times 1 gives us 2. So you have 2 add y is equal to 21. What number will you add to 2 to give you 21? The number is 19. Easy, because 2 plus 19 is 21. It means that when x is just 1, y is going to be 19. That's clear, yeah? Did you notice something here? All I did was to subtract the number 2 from 21 and I got 19. Okay, the next pair is gotten. What about if x changes to 2? If x changes to 2, what happens to y? Let's check this out. If x changes to 2, this will become 2 times 2. 2 times 2 is 4. What number will you have to add to 4 to give you 21? Think, the number is 17. So y is going to take the number 17. This is also clear enough. What if x changes to 3? When x changes to 3, what happens to y? Okay, let's think about it. Instead of 2, this changes to 3. 2 times 3 is 6. Therefore, what do we have to add to the number 6 to give us the number 21? That number, 15. Therefore, it means that 6 add 15 is 21. So y is going to take the number 15. Now, do you see something here? Notice a pattern. As x is increasing by 1, y is reducing by 2. So we can easily find all the values of y without solving so many calculations. And easily, I can do it like this. So we will say that when x is 4, when x is 5, when x is 6, when x is 7, when x grows to 4, y is going to reduce to 13. When x grows to 5, y is going to reduce to 11. When x grows to 6, y is going to reduce to 9. When x grows to 7, y is also going to reduce to 7. When x takes the value of 8, what happens to y? Y is going to take the value of 5. When x takes the value of 9, what happens to y? Y is going to reduce to 3. When x takes the value of 10, what happens to y? Y is going to take the value of 1. If I go one step further, y is going to turn negative. Watch. When x takes the value of 11, y is going to turn negative. 1 minus 2, negative 1. But the rule says x and y are positive numbers. Therefore, we can't work to this level. The highest value that x can take is 10. And the highest value that y can take is 21. You can't go beyond this. So this does not extend to infinity, just like some other examples we did earlier, extended. Now, the last example we are solving is this rectangle. We have a rectangle with a length of z and the width of y, and the area is given to us as 15 centimeters square. Our work here is to find the value of 5y minus 3z. How can we solve this? We need a little thinking. To do that, remember that the area formula, which you know, the area of a rectangle, the formula is length times width, or length times breadth. Our length here is z, and our width is y. An important thing to note here is that z is always more than y. That is to say, the length is always greater or longer than the width. Therefore, the value of z must be more than the value of y. So, for us to be able to solve this problem, remember the area you are given is 15. So, what this involves is we just need to find all the numbers that will give us 15 when they are multiplied together. In that case, we'll need to look for the factors pairs of 15, which are 1 and 15, 3 and 5, and 5 and 3 at the same time. Okay, we can't repeat numbers, therefore it's 1 times 15 and 3 times 5. They're just the two numbers. Since z is more than y, it means that z is in this column. This is column for z. The values of z are 15 and 5, while the values of y are correspondingly 1 and 3. Since we already know this, when y is 3, z is 5, and when y is 1, z is 15. These are the pairs. You can represent them easily like this. That's when y is 1, z will be 15. And when y is 3, z is 5. These are the two pairs that we have for this situation. In that case, let's solve this problem. This problem will give us two answers. Let's check it out. First, 5y. Let's try solving first with when y is 1. When y is 1, z is 15. Z is 15. In that case, 5 times 1 is going to give us 5. And 5 minus 3 times 15 is 45. 5 minus 45 will give us what number? It's going to give us negative 40. So this is the first situation. When y is 1 and z is 15, 5y minus 3z gives us negative 40. That is the first situation. The second situation is when y is 3 and z is 5. Let's check that out. When you have, this is the equation, 5y minus 3z. We are looking for when y is 3, when y becomes 3, and z is 5. What is it going to be? It's just have to do with multiplying. Don't forget that. 5 times 3 gives us 15, minus 3 times 5 is 15 also. So you see here, when y is 3 and z is 5, our answer will end up being 0. It means that 5y minus 3z will be equal to 0. That's what it is. So we have these two answers for the situation we have in hand so far. Now we've been able to demonstrate how to solve pairs of numbers and how to find two unknowns in any given equation. Did you notice that the answers are in pairs? Yes, they are in pairs because we got them from looking for the value of two unknowns. One for x, one for y, or one for a and one for b. Try pausing the video from time to time and solve the examples by yourself to see how much you have understood this lesson. As always, thank you for watching.